I will start my presentation now. My name is Karl Stapelfeld. I'm working in the office Lübeck, and I'm part of the wind application team. Today, I will introduce, Today I will introduce our new generation of power measurement terminals. They are designed for various applications. We classified them maintenance, power measurement, and power monitoring. They are ranked in terms of speed, precision, and functionality. So let me introduce you these terminals in the next slides. We will start with the EL3423 and EL3483. They are designed for energy management in industry and for building automations. Focus of these terminals is the measurement of energy and monitoring for voltage, power, and frequency supports by thresholds. A power quality factor helps to estimate the local grid quality. Focus on these terminals is essential grid parameters delivery with slower update rates. So these terminals are good for economical applications and suitable for cloud-based analytics using our IoT couplers. So coming to the power measurement terminals. Two candidates I will introduce. These are the EL3443 and EL3453. They are designed for power measurement application, mainly in the area of process control and machine analysis. By the way, they are successors of the older EL3403 and EL3413, which may be already known from past applications. A full set of RMS grid parameters, including harmonics, are supported and are calculated internally by the terminals itself. As an add-on, we have a high-resolution frequency measurement to allow measure and evaluate the grid stability. The keyword in the background is the virtual inertia evaluation. As another add-on, we have a distributed power measurement system, which one voltage and multiple current measurement points realized with one EL3443 and multiple EL3446. I will explain this later in my application slides. So then we come to the power monitoring terminals. Here I have two candidates. One is the EL3773 and the other is the EL3783. They are designed for analyzing of three-phase system based on instantaneous values. Both allow a simultaneous measuring of all 6 channels, that means 3 voltage, 3 currents, based on oversampling principles, with a resolution down to 50 microseconds. Together with the TF3650 PLC library, a full power quality analysis can be realized. Also, the raw values as part of the PLC dataset helps to deep analyze grid faults. So here's the one candidate I explain a little bit more. This is our EL3453. This terminal integrates all power monitoring and power analyzing functions for the voltage level of 690 volt AC 3-phase, which is very typically in the wind turbine drivetrain, like directly connected to the generator. For easy integration, the customer reads already scaled process data as 32-bit real in standard SE units. That means voltage, amps, watts, and so on. The RMS update rate is the same, but RMS means true RMS update rate is the same as the grid period. It means 10 milliseconds at 50 Hertz grid to allow fast reaction, for example, for low voltage ride-through detection. This I will also explain in one of my later screens. Also, we have integrated statistic functions like minimum, maximum, and average calculation. This is all done by the terminal itself. With an extra force current channel, we are able to calculate neutral and error fault current. For this high resolution frequency measurement, we have implemented a zero crossing detection with a precision down to 1 microsecond. Also, this is new. In November this year, we can offer now a factory calibration certificate to document the given accuracy of individual terminals before leaving the factory. So, introduce the EL terminals. For all the existing designs with KEL terminals, we have now introduced the KEL3453 twin. It's an identical twin functionality, identical twin of the EL3453. So this is available now. Another candidate part of the power monitoring classification is the EL3783. It's also designed for 690 volt AC three-phase systems. As explained before, we have a resolution of 50 microseconds based on oversampling principles. Some highlights we have here implemented. First is the extended range of voltage and current of 130%. And in case of a short circuit or a near grid fault, we want to analyze even this very high current, which is maybe 9 times higher than the rated current. We can automatically switch the measuring range from 1 amp to 5 amp in one cycle. So for the 1 amp range and the 5 amp range, we have the same resolution, but in case of a fault, we can analyze rated and overcurrent situations in details. For analyzing this raw data, we have implemented a power monitoring library, especially for these two terminals, to allow the customer an easy power quality analysis of the connected grid. Another variant we have implemented, because a lot of customers ask for 100 volt voltage transformer terminal. So this variant is available now and allow to measure medium voltage grid connection points. Coming to the voltage range and current range, this diagram overviews typical applications with our terminals and the voltage and current ranges. So we have on the x-axis, we have the different voltage levels. We start first with the 400 volt low voltage, which is more typical for actuators like motors and pumps. Then we come to the 690 volt levels, which is typical for generator, converter, so the main low voltage distribution, the wind turbine. And above 690 volts, we are coming to the medium voltage. Therefore, we need extra voltage transformers. For this, I have explained, we have for all of our terminals also a 100 volt variant terminal available. So, and you can see here, we have for all three-phase systems, we have the corresponding terminal. Also, we have some terminals, which is for example, the EL3773 and 3443. They also allow DC voltage measurements. Then we come to the different current ranges. We have the 1 amp, which is almost standard, 5 amp, which is also used for all the applications or maybe high power applications. We have also variants on the 400 volt range and on the 690 volt range. We have a parameter to configure, or as explained for the power terminals, we have an automatically switch from the 1 amp to the 5 amp range. And above 5 amp, we can offer various split current transformers, which we are summarized in our SDT family. In one of my slides, I will explain this family later. So you can see our terminals are prepared to addresses the wide voltage and current range in all power applications. Yes, to address this wide range of current measurement, we have now a new family. We call it the SCT family, or split current transformers. Yes, there are different housing and different concepts, from 1 amp up to 5,000 amp, and different accuracy classes up to 0.5 and different types. So we have the ring type here. We have the for one phase and for 3 phase, and for simple application we have the split core transformers. So finding for your application, you will find the current transformer for you. Maybe we can also support you. And last but not least, as requested by many of our customers, we offer now an add-on cover for protect our power terminals as a contact protection. This avoids to separate these power terminals in special housing, especially when you connected 400 or 600 watt anti-volt wirings directly. So this was a short overview of some of our power terminals, but more interesting, I will show you some application with these terminals. One typical application I see, and this is I think the common way how to implement, is our wind turbine with the drivetrain and with the generator, converter, and main grid connection. So we will start here at the cell at the generator side. Directly at the stator of the generator, we can measure maintenance and protect the generator by one of our terminal. Maybe it's a 690 volt generator type. You can use directly connected EL3453, and we will use the current transformer to measure the power, harmonics, and imbalances, and so on. Second, we are maybe interested at the main connection point at low voltage and the medium voltage level, the power, and the our grid parameters, mainly on the medium voltage side. And we are interested on the of the consumed and the delivered energy, which might be also our gain, and also the power quality at the grid connection point. For this, we can use, instead of the EL3453, also the EL3783, which allow you to measure also the instantaneous values for grid fault analysis. Last but not least, using all these powers on the different measuring points, you are able now to estimate the power losses of converter, transformer, and of the auxiliary power. And if it's not enough, and you have some special ideas how to for extended diagnostics of motors and pumps, you can add on our EL3443 and with several EL3446 to build up a distributed power measuring system for measuring the individual factors like motors, pumps, and fans. So yes, what is this distribution power measurement? We find out that yes, our EL3443 is right to measure 3 voltages and 3 currents, but for a distributed voltage power system, we have only one. Typically, we have 1 voltage, but we have several measurement points for the current. So then, for this, we have now implemented the EL3446, which allow you to measure 1 voltage but several current measurement points. And at the end, we have the same functionality at one EL3446, but we have multiple current measurement points. This also reduces the cost. Another application which might be more interesting, and I found out in my career, which is one of the most difficult points in a wind application, is to allow the wind turbine for a ride through a low voltage dip. We call it LVRT capability. And this voltage dip is mainly triggered by a near grid fault. Modern grid codes require the LVRT ability in a defined voltage over time envelope. Especially the earliest possible detection is essential to prevent a drivetrain or overspeed especially in high load wind operations. So even a 10 millisecond delay in detection could already give you an overspeed. So essential is a very fast detection. In existing application and old application, we find a lot of monitoring units using extra field buses, and maybe with not optimized RMS calculation. So now I will introduce you our terminals. For this, I have add a reference generator which allow voltage dip as a reference with a defined envelope. And here you see the result. So our standard terminal is the EL34, but also the EL37, with their integrated and external calculated RMS values, are able to follow the reference as fast as possible based on the RMS values, which are updated synchronously each zero cross of a grid period. So based on the principle of the RMS calculation, we have after 1 or 2 grid cycles already the event, and can maybe after detecting the event do some extra stuff, maybe to the pitch controller. But maybe this is not fast enough. So following the green line, we have user application with the EL37. Remember, these terminals are delivering the instantaneous AC voltages. And together with the steady evaluated grid angel, a field-orientated voltage vector can be calculated as DC, and which is much faster than the RMS values. So these DC calculated values is now possible to implement an ultra-fast LVRT detection, which has a delay not more than 1 milliseconds compared to the reference. So you gain the minimum 10 or 20 milliseconds compared to a standard application. Yes, now we come to another application I'm very interested in. I have some forwards. VGrid can be supported by active power injection when a higher frequency change above a certain frequency level is detected. This kind of grid services to stabilize VGrids is required nowadays at wind farm control level. Base of the realization is the quality of the frequency measurement in terms of resolution, accuracy, and update rate. So for this, I have built up a small test rig with a reference generator, our Omnicon, with a very fine accuracy and small drift, and programmed a frequency ramp with a small step change of 1 millihertz. And here you see some plots. First, you see the ramping of the frequency, and you see some signals which are playing around the reference. Okay, reference you can't display, but I can display some of our measurements from our terminals. So I'm using the EL3443 and also the EL3783 together with our library and together with the custom application. Zooming in, you find here, that not a surprise, that our terminals following the steps changes of the frequency very smooth, and based on the fine resolution, we are much near to the reference as maybe other terminals with other concepts. So compare with other devices, our terminals provides high resolution and fast updated frequency. And this is the basis of a good and fast enough rate of change of frequency evaluation required by the latest grid codes. Latest grid codes, looking in the wide range of the internet documents, I find document from the European Network of Transmission System Operators. This is almost the master of everything. And here I find a table, and inside this table, it shows that for this centralized generation control, and this might be our wind turbine, at minimum, we should have a resolution of 10 millihertz, and also for the ROCOV of 10 millihertz per second. But for a centralized generation control, this is our wind power control, we should already have a 1 millihertz resolution. And based on this requirement, I can say that we can follow these requirements with our terminals. Yes, another idea is using our EL3453 as the extra channel for neutral current measurement, which is almost standard. Now we're coming to our condition monitoring team. To our condition monitoring, we can detect voltage and current imbalances. That's easy. We can also protect our generator, but also we now can detect preparation of windings and isolation errors by measuring the neutral conductor current. As an alternative, we can also measure the earth fault current by summarize all phase and neutral current together. And this is also a good condition monitoring feature for a long-term analyzing of our generator. So now we're coming to the end of my presentation. And if you have any question, you can make this. Otherwise, I will finish now. Thank you.